for the second portion of 1.4, linear functions and slope. Hopefully a lot of this has felt like a review of graphing in Algebra 1 or Algebra 2. You might have not seen that material for a bit, especially if you just took geometry, but as we see here, a lot of it is coming back, and a lot of it is going to be material that we want to see and hold on to as we move through pre-calc. So with 3, they give kind of a vague question here, asking us to find the x-intercepts and the y-intercepts for the function 4x minus y equals 4. So this isn't really asking us to graph this out, although we could. The x-intercept and the y-intercept we want to be precise with, and we will eventually in time graph this, but just starting off with the general question. So what is going to be the coordinate of any x-intercept or y-intercept? I'll give you a moment for this. Meaning, do we know any of these coordinates? Do we know the x term or the y term? Well, hopefully for the x-intercepts, it's going to be intersecting on the x-axis. So one of the coordinates, if it's only on this line, is going to have to be where y is 0, because we want this point to stay on the line. We don't want it to go up. We don't want it to go down. We want it to stay steady where y equals 0. And for the y-intercept, this is only going to be a point on the y-axis going vertically, not moving to the left or to the right, away from the y-axis. So hopefully you were also able to say that the x-coordinate is going to have to be 0 if we're talking about the y-intercept. And with this in mind, we can take this further because we have an equation. Although it's not graphed, we can definitely take this further just based off of one of these points and knowing that one of the coordinates has to be 0. So for this first one, I'll start by going for the x-intercept. I know I have 4x. I'm then deducting the y-coordinate, which is 0. This should be equal to 4. Well, 4x minus 0 just leaves us really with 4x equals 4. Dividing both sides by 4. One-step equation here, channeling some algebra. 4 divided by 4 is just going to be rewritten to 1. So we know that our x-intercept is going to be positive 1. We can even graph this out if we want. If we're going for the x-intercept, x-intercept we just got. If we're going for the y-intercept, we know the x-coordinate has to be 0. We're then subtracting y. This should be equal to 4. 4 times 0 is going to be 0. We're then subtracting y. This should be equal to 4. And so this might be an odd placement because normally we have a positive variable equals some number, but we have a negative y equals positive 4 here. So you might be asking, what can we do? Well, we know that if we have a negative y, if we're taking the opposite of y, it should be positive 4. If we switch around the signs for these, we can claim that y is going to have to be equal to negative 4. So that's what our y-intercept is going to be, negative 4. So we know we have our x-intercept, we have our y-intercept. These are 2 points. If we wanted to keep graphing this, we could. Our slope is moving over 1 and then up 1, 2, 3, 4. If we do the same thing here, over 1, up 1, 2, 3, 4. We can eventually graph all of these out. Well, all the points, although it wasn't what we were being asked to do. Sometimes it's nice just to show that we know how to take it further. Getting us this line here. Cool. If we take this further for the final problem, we're being asked to use the slope and y-intercept to graph the linear function 6x minus 3y equals negative 2. So we're being given what kind of equation here? I'll give you a moment to think. What kind of equation are we being given? Well, hopefully you were saying that we're being given an equation in standard form. And they're particularly asking us to use the slope and the y-intercept to graph this linear function. So luckily, from standard form, we can go to slope-intercept form. And I'll give you a moment to think, how can we do this? So how can we go from standard form to slope-intercept form? From this to an equation where it's y equals mx plus b. How can we go to that? Well, we know that y is isolated, so we could begin to isolate y. So if we isolate y from standard form, that will get us where we need to be, because it's pretty easy from there to decide what the slope is and the y-intercept. So if we rewrite our equation, we have 6x minus 3y equals negative 12. If we begin to isolate y, we can deduct this 6x from both sides, leaving us negative 3y equals negative 6x minus 12. Y isn't quite isolated yet, but we can divide both sides by 3. Negative 3. Y is then equal to all of this being divided by 3. You can think of this as negative 6x divided by negative 3, then subtracting 12 over negative 3, rewriting this to 2x, and we are going to be adding on 4. So hopefully from this, you're able to say that your slope is going to be positive 2, or you can write it as positive 2 over 1 if you want to know the rise and the run pretty quickly. The y-intercept is going to have to be positive 4. So we can graph this out also if we want. So we know that the y-intercept's 4. We know that the slope is 2. So if we run 1 unit and go up 2 units, that gets us another point. We really only need 2 points here. If you decide you want to backtrack, just be consistent because our slope's positive going up and to the right. So we could go down 2 over 1, down 2 over 1. Hopefully you start to see this pattern here. It's a pretty easy one since it's linear. Throw in some arrows so that we know that it's continuing to the left and to the right. That's as good as it's going to get. This line's actually pretty awful. I could have drawn it a lot straighter. I guess I'm just being lazy. So that happens.